All right, this is another similar triangle thing. Now, there's a big explanation. If you look through it on page 33, there's a big explanation on how they get to this thing. I'm not going to go through that. If you want to go through that on your own, read it. And there are actually three similar triangles here. There's this triangle right here. Okay, do you see that one? There's this triangle here, and where's the third one? The whole big triangle. Okay, and all three triangles are similar to each other. Again, I'm not going to go through the reasoning why they are. That's more of a geometry thing. You should have hit this in geometry anyway, and this is just review, okay? So I'm just trying to go through real quick. So what I'm going to do is just go through and just hopefully remind you how to solve these things. Now this is perpendicular, so that's a right angle right there, and this big triangle up here is also a right angle, okay? So when you have a big right triangle, this thing right here is called the altitude or the height. Depends on what you want to call it. Okay, a lot of times they call it the altitude. If you have an altitude drawn to the hypotenuse of this big right triangle, do you hear what I just said? This is an altitude, and it's drawn to the hypotenuse, right? That's the hypotenuse because it's opposite the right angle. So if you have an altitude drawn to the hypotenuse of a right triangle, the stuff that I'm going to show you will come into play. And it's all because of similar triangles. But again, I'm just going to show you how to do these things. I'm going to, before we actually put some real numbers in here, let's do this. We'll call that H, and we'll call this X, and we'll call that Y. All right? So I'm just going to label it with letters right here. I'm going to set something up. There's three different scenarios that I'm going to have you look at. All right? One is this. I'll tell you what. Let's see if I can make this a different color. All right? Just so it stands out a little bit. Good. All right, so let's talk about H. I call H because it's the height. All right, let's talk about the height. That's the easiest one to do. What I'm going to do is this thing called a geometric mean. Without going through a lot of explanation for it, the geometric mean, so for instance, if I give you two numbers, I don't know, let's say 3 and 5, and I say, what is the geometric mean between 3 and 5? This is what you would do. You would set up a little ratio. That's supposed to be an equal sign right there. You set up a ratio, and you're going to put X on the top of one, and you're going to put X on the bottom of the other one. Okay, they're diagonal. You could have put the X here and here if you wanted to. It doesn't matter. I always put it on the top of the first one, the bottom of the second one. All right, so this is a geometric mean. So the geometric mean is actually X. That's what I'm solving for. Between, it'll say, what is the geometric mean between 3 and 5? So where do you think you're going to put the 3 and the 5? Well, the only two spots here, right? So 3 here, 5 here. Do you think it makes any difference if the 5 goes here or the 3 goes here? No, it doesn't, because what are you going to do to solve for X here? We've talked about this on several occasions. You're going to do what, though? What's the process? You're going to cross multiply. Good. Okay? So you're going to cross multiply. So whether I have the 3 here and the 5 here and the 3 here, doesn't make any difference because I'm just going to multiply them together anyway. You get it? So look, if I was going to solve for this, cross multiply. X times X is X squared. 3 times 5 is 15. Solve for X. X is what? Square root of 15. Follow? That's called geometric mean. Do you remember that from geometry at all? Yeah, that should be something that was taught in geometry. I taught it a little quicker here than I would in geometry, but again, it's supposed to be a review. So it's called geometric mean, M-E-A-N. Mean is kind of like an average. Do you remember doing that? Okay, it's kind of like an average. It's not. This isn't an exact average. It's definitely not the average between 3 and 5, but we won't worry about exactly why it's called geometric mean. Let's just learn how to do these. So that's how you do a geometric mean. I tell you, I was going to erase that, but I'll just keep it up there. Now look at this. H is also a geometric mean. But it's the geometric mean between what two numbers? Well, it's between the two segments of this hypotenuse. So H is the geometric mean. So look what I do. I set up a proportion. If H is the geometric mean, I'm going to put an H here and an H here. But between what and what? Not between 3 and 5 all the time. Between what? The length of this segment and the length of this segment. Do you see how this big hypotenuse is broken up into those two parts? Well, H is the geometric mean between this number and this number right here, whatever they are. Sometimes they give them to you, all right? And you would just put those numbers here and here. Who knows? They might give you this as a 3 and this as a 5, all right? You would put it in there. So what do we say? It's between what? X and Y. See that? We'll put some numbers in there in a few minutes here. So H is a geometric mean. That's why I put it in a different color. There's a couple more geometric means here. And let's put those in. Let's put them in this nice blue. All right, so let's click on that. Oops. There we go. So that's blue, and let's see. Yeah, we'll make that whole thing blue. They're also geometric means, those two right there. Now I put them in the same color because they're very similar to each other. Actually, you know what I should do? Forget that. I'll just keep it all in black. Watch, A is also a geometric mean. So H is a geometric mean, and so is A, and so is B. But let's find out what A is the geometric mean between. So watch what I'm going to do. If A is a geometric mean, where do I put it? Top here and, oops, bottom here. Everybody with me? Now, it's the geometric mean between, I'll tell you what I'm going to do, make this a little easier. To see this whole entire segment, let's call it, you could call it x plus y. It's not xy, it's x plus y, like we did before, remember that? Okay, so let's just call the whole thing z, just to make this a little easier, is that alright? So watch, A is a geometric mean between the whole thing, which is z, and the segment of that whole hypotenuse that's adjacent or closest to this A, which is what? It's x, right? X is closest to A, isn't it? It's adjacent to it. Okay, y, it would be closer to B, wouldn't it? So it's the x. So what is this, the geometric mean between? The whole thing and the segment that's closest to the A. So z and what? X. Now B is kind of like the same thing. Except now B is the geometric mean. What do you think? Between the whole thing, again, what's the whole thing? Z, right? And the segment that's closest to the B this time, which is the Y. And that's how you set it up. So those are your three scenarios. All right, there's one. That's for the altitude or the height. This right here is for one of the sides, and this right here is for the other side. You with me? So watch. This red one right here is the geometric mean between these two segments right here. A is the geometric mean between the whole thing and the segment that's closest to the A. B is the geometric mean between the whole thing, Z, and the part that's closest to B, which is the Y. Think you can do that if there was numbers in there? Well, let's try one. Alright, I've set up a situation right here where I gave you the actual lengths of the sides this time, these two segments. Alright, they're not just X and Y and Z. We're actually going to solve for A, B, and H. I think H is the easiest one, the altitude. So let's find H first. Okay, so we set up a geometric mean, and what are we solving for? H, right? So H is a geometric mean, so I'm going to put an H here and an H here. Now, it's between what two sides? H is a geometric mean between what and what? 8 and 4, that's right. So all you got to do is stick an 8 and a 4 here and then just solve for H. It's pretty easy, isn't it? Once you figure out this whole routine, it's actually fairly simple. Let's set the rest of them up before we actually solve them. All right, what are we going to solve for now? Let's solve for A. So I'm going to put an A here and an A here because that's my geometric mean. So it's a geometric mean between what and what? Is it 8 and 4 again? Is it 32? Come on, let's think of, we've talked about this on a couple occasions now. It's not 8 times 4, what is it? It's the whole thing. You don't multiply those to get the whole length, right? Yeah, you add them up. So it's 8 plus 4, which is 12. And which one? We're solving for A, so which one of these do we use? The 4, right, because 4 is closest to the A. So we put a 4 right here. Let's do another one. Let's solve for B. So B is the geometric mean, so we put 1 here and 1 here. Between what and what? Between the whole thing, which is 12, right, and the segment that's closest to the B, which is 8. Right with me? Now, we got them all set up. Now it's just a matter of doing some basic algebra and solving for it. So we cross multiply. Now watch how I cross multiply, though. H squared equals, watch, it's 8 times 4, isn't it? Okay. What I'm going to do is, I want to write this so I can simplify my radical. I'll just show you a little hint. 4 times 8. Now I'm not going to write down 8. I'm going to break that down. What's 8? It's 4 times what? 2. You with me on that? Now why did I do that? I did that because I know I'm going to take the square root of both sides. Right? If I take the square root of this, what's 4 times 4? What's the square root of 16? It's just 4. Now 2, what do I do with that? I just leave it inside of there, and so h is 4 square root of 2. That's the way it's going to look in the back of the book. If it's an odd problem, you look in the back of the book, your answer will look like this. So I want you to understand why it looks like that. And that wasn't too hard, was it? Simplifying that radical. And that's what we're going to do with all these. So let's do this one. Cross multiply, a squared equals, look what I'm going to do. I'm going to go 4 times 12. So there's the 4. Let's break 12 down. Now you're not going to break it down into 2 times 6. What would be a better way to break it down? 4 times 3, right, because I can take the square root of 4, right? So let's do that. Take the square root of both sides. Sometimes I just cancel it out here. I don't have to show that square root over there. So a equals, look what we got here. 4 times 4 is 16, so the square root of 16 is 4, right, and then square root of 3. So that's a. Should have circled h. Make sense? It's not too hard. Solve for b. So b squared cross multiply equals this times this. 8 times 12. Well, let's do, I don't know, let's do the 12 first. So break 12 down. What's that? 4 times 3. And let's break down 8. It's 4 times what? 2. Everybody see that? I didn't go 12 times 8, did I? And then try to simplify that. It's a lot easier to take it with the smaller numbers and break it down easy like this. So I'm going to take the square root of both sides. So b equals, and that goes away. Now look, these aren't together, but they're still inside there. 4 times 4 is 16. Square root of 16 is just a plain old 4. So I'm done with those. What about this? 2 times 3 is 6. Can I take the square root of 6? Can I simplify that? Nope. So I just write the square root of 6, and that's what b is. And that's what your answers are going to look like. There's h, there's a, there's b. And those. You can
simplify it, should you?
Yes, you should. Okay. And if you look in the book, look at the example on page 33. At the bottom of 33, they write it exactly the way I wrote it. See it? So I want you to be able to write it like that, because the back of the book, when you know, if it's an odd problem, you got the answer to it, they're going to have it written like that, and you need to be consistent with what they do. All right, look at that. We finished lesson 3. How many days that take us? 3. Okay. We have one more lesson, lesson 4, where it might take us a day or two. It's actually kind of fun. In fact, they deal with compasses. Yeah, I couldn't think of it.
Teachers, please excuse the interruption. Mrs. Arterbridge, 8A, please go to the Pusey Center for pictures. Mrs. Beatty, you are on deck. Thank you.
If you have a compass, you want to bring it in, you can. I've got plenty of them. There's not many of you, so you can use the compass that I have. They might not be the best ones, but if you have one that's real nice and it's tight and it doesn't wiggle around, you know how those compasses you get from school and they got a little rivet in there and then they get all loose. I think most of them are pretty decent. If you don't want to bring one, you don't have to, but if you have one, you know, and you're like, hey, might as well use it, I paid for it, then you can bring it in, and we're going to use a compass tomorrow, okay? All right. We'll shut this down, and let's see, how much, we got what, 5 minutes? 35, yeah. So maybe we can go over one question from the homework if you don't know how to do those.